Hello Algebra 2 students, this is a video for example, I gotta get back to the screen, example 5 for section 2.4. Factor a sum of squares. How can you use complex numbers to factor a sum of two squares? You can rewrite the sum of two squares as the difference of two squares, x squared minus negative y squared. How can negative y squared be a perfect square? Well, if we use imaginary numbers, they can be. You can think of negative y squared as negative 1 times y squared. And since negative 1 equals I squared, then you can replace it and you can make it I squared y squared. Alright, so x squared plus y squared can then be x squared minus yi squared. And you don't have to understand all of that gobbledygook. You can just understand that x squared plus y squared can be broken down into x plus yi, a real part and an imaginary part, and the complex conjugate for that, x minus yi. Notice these are complex conjugates like we just used for division problems. Okay, so the factors of x squared plus y squared, the factor that, you would have the complex conjugates. Okay? Let's see another one here. All right. Now 12 isn't a perfect square and neither is 3. But 12 and 3 have a common factor, so they're going to factor the 3 out. They factor the 3 out, and they're left with 4x squared, which is a perfect square, plus 1, which is a perfect square. So they're going to break it down into 4x squared minus I squared, which is a 1, right? The coefficient's 1, that's key. So then you take the square root of 4x squared, which is 2x, and the square root of I squared, which will be I, and we have 2x plus I, 2x minus I. So the factors of 12x squared plus 3 are 3, because we factored a 3 out, and then the complex conjugates, 2x plus I, 2x minus I. Alright, they give us two problems for us to try. If you're all set, give that a shot and come on back. Alright, can I factor anything out of both? No. Is this a perfect square? Yes. Awesome. It's 2x times 2x. Is this a perfect square? Yes. But it's a plus instead of a minus, so I know I'm going to have the complex conjugates. I'm going to go the square root of 25, which is 5. So I'm going to have minus 5i times the complex conjugate of it, 2x plus 5i. It can be as simple as that. I mean, I didn't have anything to factor out on that one. Probably the other one does. Okay? You just take the square root of this and the square root of this, but because it's a plus, we have to bring in the imaginary part, and it will all work out. If you want, give this one a shot. Looks like we can factor something out first, and then go for it. 8y squared and 18. I can take a 2 out of both. Can I take anything else out of both? Nope. So I'm going to take out a 2, and I'm going to be left with 4y squared, which is nice because that's a perfect square, plus 9, which is nice because that's a perfect square. So we have the sum of a perfect square, which is going to break down into the square root of y squared, the square root of 4y squared, which is 2y, plus the square root of 9, which is 3. Don't forget the imaginary part, times its complex conjugate, 2y minus 3i. And don't forget the 2. So to factor it, I have 2 times 2y plus 3i times a conjugate, 2y minus 3i. Okay? Your teacher can assign to you some of these problems, 34 through 39. That's it for this video. Have a great day.